I'm erasing it now. Can I erase it?
Go for it.
Okay, so, here's what I want you to do first. If I put, can you see me in there?
No.
Can you see me here?
Yeah.
Yeah.
So if theta is negative pi over 3, and you're asked to find the 6 trig functions, can you do that?
Yes.
Yeah.
Partially because I know the stupid, but
So the first thing is locate the angle. The second thing is find the coordinate that goes with that angle. And the third thing is
Do the
evaluate them with the formula. So that's the first set of steps we're doing. So where is negative pi over 3 as an angle? If you think about it like this, is it in quadrant 1, 2, 3, or 4?
4,
Then 4. Is it closer to the x-axis in the middle or farther down?
further down.
You guys are so
Like
good
the
at
last
this.
one.
Nice. Okay. And then if this is negative pi over 3 this way, that coordinate is still the same. So what is that coordinate that goes with that? Which one? Farther from the x-axis.
1 half negative.
You got it. So that's the coordinate. That is your x, that is your y. And then as you find your 6 trig functions, you do it exactly the same way as we did yesterday. So I'm going to let you do that really quick. We're going to do sine of negative pi over 3, cosine of negative pi over 3, tangent of negative pi over 3, and then cosine goes with secant, sine goes with cosecant, and tangent goes with cotangent, so you find your reciprocals for those. So if you can find the first 3, then the other 3 follow from just flipping them, taking the reciprocal. So I'll give you a second to do that, just to make sure that you can still work through it. And then it's like something that you might add to your unit circle if you want to use it to study. And then we're going to talk about even and odd functions. These guys right here.
We just put it in our calculator.
No. Nope. It's all mental. All mental. All from the unit circle. So if you know that that's the coordinate, what is the sign? Can you guys remind me?
I don't even know.
Y
Sign was x or y over x.
Y over X. The Y over 1.
whatever.
It was the y over 1, but y divided by 1 is just y over 1. So it's just the y value. And the cosine is
The X value.
the x value, x over 1. And then the tangent,
Y over X.
so think about tangent like slope.
So 1 half over.
It's, if you found the slope in algebra, what would you do?
You would do y equals mx plus b.
That's what.
Okay, that's the slope intercept formula, and you found slope.
Oh, rise over run.
Rise over run, but what's the way we do it?
Why am I?
Well, couldn't you just put can't you just put the Y numerator over the X
Yeah,
numerator?
so how do we remember that? Because people are wanting to put the x on top and the y on bottom.
Y is over X.
So tangent is
Rise
not finding
over
the slope.
run.
It is the y over the x. The change in the y is over the change in the x. She did say that, I heard her.
How do I do that?
So we get that over that.
That's.
And then you either keep, change, flip, or you remember that these both have the same denominator, which allows us to cancel those out. To get the square root of negative square root of 3 over 1, and then that's just negative square root of 3. So you have that option of keep, change, flip, or just simplify. All these fractions have a denominator of 2, so they will be. Then we would keep, change, flip.
I forgot how to keep change.
Alright, so sine goes with CSC cosecant. And if we take the reciprocal of this, reciprocal means to flip. So it's 2 over the square root of 3, which is negative. And sometime in the future, this will be okay to leave on the denominator, but for now, we rationalize, that's called rationalizing. So we get this. What about the secant? The secant takes the cosine and flips it. And the cotangent takes the x over the y. So I like to go back to this one and say if this is what it was, and I flip it, and it's gonna be 1 over square root of 3. Again, that's okay, that's the correct answer, but for now, we like to rationalize. And we get,
So we don't put any of that in our package.
no, all brain power. All brain power. Now, I know some of you are gonna cheat and you're gonna type the fraction into your calculator and it's gonna simplify it for you. You know who you are, yeah.
On the test, do we need to memorize like how to find sine cosine?
The formulas will be given to you, so it'll say
Like y over 1
sine
stuff?
equals y over 1, cosine is x over 1.
Okay.
Okay, so that's where we're at for now. If you want to add to your unit circle the tangent values, because I think sine and cosine are easy for you because it's x and y. But there's a pattern in the way that these work out. Because every one of these ordered pairs, they have something in common, right? If we're here at negative pi over 3, if we go to positive pi over 3, we have the same coordinate, it's just a positive and a positive. And when we're in quadrant 2, we have the same coordinate, it's just a negative and a positive, and then it works out the same way all the way around. So if you want to be that guy or that girl that remembers the tangents, so you don't have to always calculate them, then this might be a time saver for you to look at the unit circle this way. Okay, so here's the unit circle, and this is the first, make that a little bit shorter. This ordered pair right here is 1, 0, so if I did y over x, the tangent for this one will be 0. The tangent for this one will be 0. 1, comma 0. If I take the y divided by the x, we'll get 0. When I go to the 30-degree angle, this one will always have a 1/2 on top, a square root of 3 over 2 on the bottom. So this one will turn out to be the square root of 3 over 3 for the tangent. If I go to the 45-degree angle, you guys told me yesterday that if I take the square root of 2 over 2 over the square root of 2 over 2, you get just 1. You get the same number. So that'll be 1. And then we just found this one. What's this one gonna be? Square root of 3. And then if we go up to here, this is the point 0, 1. So if I take 1 divided by 0, that's undefined. So the tangents go in this order around the circle. And they repeat over here and down here and over here. It's just positive or negative depending on your location. So in this quadrant, because the tangent is relying on y and x, since the x is negative, the tangent in this quadrant will be negative. It'll be these same values, but it will be negative.
Negative.
So this one would be negative square root of 3, this would be negative 1, this would be negative square root of 3 over 3, and then this would be 0. So they just repeat around there. In this quadrant, x is negative, y is negative, so tangent will be positive.
Because A, it's not your land. B, you mentioned.
And in this quadrant, what will happen in that one? Tangent will be negative. So same values as this around the circle, but depending on where you are.
Is that
So,
according to the x-axis as well?
oh yeah. Yeah, so from here, yeah, from there, from there. And then over here, up this way, up that way. Yeah. Then down there, down there, down there, the same way. And then this one would be undefined just as that one is, and that one will be 0 just as that one is. And there's a pattern. If you don't wanna ever have to think about those fractions, where we do this division, then, you've got that. And, after doing this for 100 years, my brain just knows which goes with which. And so I wanna teach you how to do all this dividing, because you can do that every time if you need to. Or if you're good at remembering single numbers, then you could do that. Yeah? Okay, so, that's just a little trick.
Okay.
The new thing in 4.2 is that we're gonna look at even and odd functions. And we talked about even and odd functions in college algebra, but you guys might not remember what they were. If you'll draw this chart on your paper, I'm gonna write some extra stuff on it. So on your test, you will be given those formulas.
Like that.
And yeah, and you will be asked to, it'll say, use the even and odd identities to solve the problem. and then you'll have to use these to solve the problem. You'll have to show that you use one of them to be able to do it. So even and odd. And it's really pretty easy to remember which is which. So even, if you think of something as even, as a behavior, what do you think of? Even as a behavior. Just in life. Even.
Life is a fair.
No, but if I say someone's behavior is just even.
Good.
Good, it's pretty good.
It's just
Positive?
average.
Yeah.
It's average.
Or like it stays the same.
Yeah.
It just even keel all the time.
Yeah.
Well, not all the time.
I think it's
be
But
like-
that's, so but even would be like this.
Yeah.
Even is like it just stays the same the whole time.
Okay.
And what about somebody's behavior is odd?
They're weird.
It's obscure.
It goes like, yeah,
It's
their
all over
behavior's
the
all
place.
over the place,
Yeah.
right? It changes.
Uneven.
It changes from positive to negative, it goes from negative to positive. And so in real life, it's kind of that same connection to these things that we're gonna talk about. So, Brian drew a little picture behind here. I'm gonna let you guys see it and then I am gonna erase it, Brian, I'm sorry. Cause I need to be able to write on here. So you've got the chart, and it's really pretty easy to use this, considering what we have to do. There's like, again, no work. You don't have to do any work. You just have to think about the process and is it positive or is it negative? Is it the same number or is it the reciprocal? So it just follows along with what we're doing here.
What's your crowd engagement on YouTube?
I don't know.
Are these just
I
the?
don't look at it.
Wait, hold on. Why does 10 not have?
Oh, this should be cotangent right here.
Yeah.
Fix that. Yes, if you wrote that down, make that cotangent.
Are these just the
I
inverse
stole this from
functions?
somebody else's slide and they didn't do the right thing. So that is
They should be
cotangent.
Are these just the inverse functions? Are these just the inverses of the original?
They're not the inverses.
What would it be titled? I see a title.
Even and odd
Big trust.
functions. Even and odd. Is it okay if I raise this?
Wait, hold on.
That should be code COT.
Okay, why is
No, the calculation's wrong, it's 69.
That must show it. That's all.
That's
So
supposed to
here's,
be there.
here's your message from Brian.
That's supposed to be
That's
there.
what I heard.
That's what-
Yeah, they're supposed to be there. Everything happens for a reason.
So
You're here for a
beautiful.
reason. No matter what it is, even if it's not to learn math, you're here for a reason.
Wow.
For some reason, we're having our life together right now.
Isn't that beautiful?
It is, you're here because.
I didn't say
Because
it.
the universe said so.
It said so, so we're here together at this.
I think the universe is there to take me out.
Okay, so, this one, I want you to write odd. And everything in that line is odd. This one is even, and this one is odd.
Is that why it's weird?
Yeah. So if you had to, just thinking about what I said about even is like even keel, it stays the same. And odd is we bounce back and forth from positive to negative, everything's up and down and changes.
Stop.
What's the major reason that this one would be odd and this one would be even mathematically? Like, what do you see? I know Brian sees it.
It's a negative X.
Because of the, what's the difference?
There's no negative.
This one has a negative in here,
Yeah, cool.
that one has a positive right there, but this one has a negative out front.
Yeah, but the other one.
But this one has a negative here, and
But
a
there's no
positive here,
negative
but this
out
one
there.
has a
So
negative
balances
here.
out.
Does it have to do with the X
So if
value?
it's odd, it's like you can take the negative off of here and put it out there.
Yeah.
And if it's even, you just get rid of the negative. It keeps it the same. So in an odd situation, it changes it to the opposite. So I'm gonna add another little thing here. So
I still don't get it.
odd, do this. If theta is positive or negative, it doesn't matter. So we may start with the positive and then we look at the negative, or if we start with the negative and look at the positive. If theta is positive or negative, we take the opposite. So if the answer is negative 1/3, then the odd function's answer would be positive 1/3. So it's always the opposite of what the answer shows up to be. If it is even, then we would say if theta is positive or negative, it doesn't matter, the answer will always stay the same. The answer stays the same. So if it's even, and I tell you that the answer is a half, then the answer will be a half. If it's odd and I tell you the answer is a half, then the other answer will be negative 1/2. It'll be completely clear in just a minute when we do an exam.
So what do we use
It wasn't ever,
the whole thing?
The whole thing.
And why we use?
So the deal is, we're trying to find a fast way to think about the way that angles work in the world of this. Just to answer your question. So if I have an x value that is, let's do a negative x on here. So sine is y, and if I go a negative x value, and maybe I make a triangle here, and I make a triangle here. This point has the same x value as that one, true?
Yes.
They both have the same x value. But what's true about the x value and the y that it gives me? This gives me a positive y,
Yeah.
this one gives me
Negative 1.
a negative y. This means that this is an odd function in that case. So for this x value, for whatever x I put in, it's gonna give me that value. If I put in a negative x, it's gonna give me a positive y value here, but also then it's gonna give me its opposite. And that's the opposite right there. It's gonna be the opposite of what it is. But what about the x value? If I go this way, how many x values are right there? Only, well, from here to here. There's just one, yeah. So x remains the same. So in that case, that's the cosine. Cosine corresponded with the x over 1. Sine corresponded with the y over 1. Here the y, it's evident that it changes, but here the x remains the same. Is that clear?
Yeah.
Is that good? Is that good? So y will change, but x will remain the same. In the way that it works in those triangles. Imagine there's a circle around that we draw. Okay, so here's an example. Somebody give me,
35.
no, we're not gonna use an actual angle. Let's do this. Given, remember that t, alpha, theta, beta, all of those represent a variable or an angle, so let's call this t. Not t. Let's do it this. Given that the cosine of t is negative 1/2, evaluate A, the cosine of negative t, and B, the secant of negative t. Using the identities that we have there, using those formulas that we have there. So the cosine of some angle t, we don't know what it is, but we know there's an angle t. The cosine of that angle is negative 1/2. Hopefully right now you're thinking about your unit circle and there's some values on there that have a negative 1/2 on them for the x value.
Yeah.
Can you see them?
This one. Alright.
They're negative x's, right? Negative cosines. So they're over here. And they're, do you know where they are? We don't need to know for this. You don't need to. Just make sure you're thinking about it. So if this is the cosine of t, and we are told to evaluate the cosine of negative t, then what will be the answer by the even function rule? The cosine of, so it's like I'm starting on this side. And then I want to know what the answer is over here. The cosine of x equals the cosine of negative x. Still the same thing, right? It's the same. Even means it stays the same. If it is even, which means cosine or secant, it stays the same.
Okay, right.
Okay, cosine of t, cosine of negative t, they're equal. Cosine of t, cosine of negative t, they're equal.
Okay, but can we do this?
The
Sine?
secant,
Can we do sine?
we could if that was a question. Yeah. All right, the secant of negative t. So first of all, you have to know what the secant is. What's the secant of that? Secant, is secant the reciprocal of cosine?
Yeah.
Yeah?
Yeah.
So if it's the reciprocal of it, then what is it?
Same thing.
2.
It's negative 2.
Negative 2.
And so the answer here, is it still negative 2?
Yeah.
Because it's the same. It's even, so it will stay the same.
Okay, can we do the same?
It's even. So cosine of t, cosine of negative t are the same. And once I find the secant of x, secant of negative x are the same. Even stays the same. Even stays the same.
Will there be questions where we have to get, like, things that aren't opposites?
Not right now.
Can this
Okay.
one be an odd, like,
Yeah.
so I can pay it?
So let's say, given that the, we'll go cosecant. Given that the cosecant of negative t equals, 1/3. So given that the cosecant of negative t is 1/3, what is the sine of t? And what is the sine of negative t? So here's how you're having to relate to what you did yesterday to what we're doing now. The cosecant and the sine are reciprocals of each other. So if this is the cosecant of negative t, what would be maybe we want to find the regular cosecant of t first. So what is the cosecant of regular old t? Based on the rule.
It's just 3.
It is odd,
It'd be negative
and
3.
so it becomes the opposite sign,
Negative 3.
but it's the cosecant.
Negative 1/3?
It's still the cosecant.
Negative 1/3?
So we didn't flip it yet.
Oh, okay.
All we did was we took the negative out of here,
Okay.
and we put the negative onto the number. So this will be negative 1/3. It is the opposite of what it starts as. So sometimes, even though these are the questions that are being asked, we won't necessarily want to look forward until we know if this is what we have and this is what the rule says. Let's find both of them first. And now we can find the sine of t and we can find the sine of negative t. So if this is the cosecant of t, what is the sine of t? Sine and cosecant are reciprocal. They're both positive t. And so that means we can flip it. And that makes it negative 3. They're both t. If they're both positive t, then they remain the same sign. But as soon as we throw a negative in there, then we have to switch it to the opposite, because it is odd. So what will be the sign of negative t if the sign of positive t is negative 3? 3. It's the opposite. And that's all about the way the rule works. So sine of t, here is, well, if the sine of negative t is 3, then the sine of t would be the opposite of it. And the way that those work. Do you want to do more examples?
Yeah.
Yeah.
And then you'll have time to work on your
No.
assignment.
No.
We'll do it at
What
home.
time we get out here?
2:09.
You have time.
Oh, then she won't have time.
Let's go with,
What is that?
let's do tangent. The tangent of t is 3/4. Tangent is 3/4. I want you to evaluate the tangent of negative t and the cotangent of negative t. Okay, so try it and see what you get. So, if it says to use the rules, use the rules. Decide, is tangent even or odd? That's gonna help you figure if you're keeping it the same or changing it. Or changing it. Or changing it.
I was texting my notes tomorrow. Yeah.
Hmm?
I was texting my notes tomorrow. So, okay. So, here's the sellers.
Your
What's the-
paper is the hardest to ever.
So you take, so you add the negative t back in, so that would make it negative 3/4.
Yes,
So that would just be the answer for A, negative 3/4.
yes.
And then it'd be the cotangent, which is the opposite side, but if it's a negative t, it would be negative 4/3. So the cotangent is reciprocal, right?
So, yeah, the cotangent would be 4/3.
It'd be negative, it's a
And it'd
negative
be
2.
negative 4/3.
Good.
Well, yes, you do.
I didn't.
Did you need these?
Yes.
Wait.
Where are they? Actually, where are they? I don't have that. I don't have the paper, I don't have that.
A year ago. Okay, so what is the tangent of negative t?
Negative 3/4.
Negative 3/4. And what is the cotangent of negative t?
Negative 4/3.
We'll just flip it, yeah. So when these are both negative t, all I've gotta do is just take the reciprocal. As long as these match, then I can do that. What would be the cotangent of that?
The code, 4/3.
4/3? Do you wanna do more, or do you wanna work on your assignment?
Homework.
Okay, go ahead and start working on your assignment, and that way I can answer your questions if you have them. And that is all. We're hoping that the tri-com eventually is going well.
Oh, it's for trying.